All right, so we are going to be looking at some trigonometric equations. We're actually going to find answers for x that satisfy this equation. Now, spoiler here, there's actually a whole bunch of them, but we only care about one or two of them typically. So the way it works is we're going to find two x values that will satisfy this equation. And what you're going to need is you're going to want that little spider web chart. Calculator is kind of optional. Calculator ruins it actually. And you're going to want this chart, the special angles chart. So before we go too far, one thing that you have to keep in mind when doing these, all right, you have to keep in mind, in this case, it's the sine function. You need to keep in mind the two quadrants where sine is equal to a positive value, because this is going to clue you in on where your solutions are. That's very important here. Now, because sine of x is equal to positive root 3 over 2, we know that our answers, if there are any, they have to be in quadrants 1 and 2. And that's because sine of x is positive, the y values, that's what the sine is kind of like, is the y values are positive in these two quadrants. So these are going to be the only two places that we look for answers. All right. So if you were using your calculator to answer this, you could just do the little inverse, not square root, inverse sine of the square root of 3 over 2. Square root of 3 over 2. And that would give you 60 degrees. And that is one of your answers. But there's two main answers that we want to get. And this really isn't the best way to do this. This is only picking up on a very little sliver of the answers. Now, in that last video, we had talked about the graph of sine. And again, you don't have to work these out quite like this. But sine of x and root 3 over 2, we're really just asking the question where those two things intersect. Now, the square root of 3 over 2, if I was to type that in on the calculator, it would be about right here. It'd be 0.86, something like that. And there'd be this horizontal line that comes through. Right? And it would continue to go forever and ever and ever and ever. Now, your calculator only found that one spot. Right? It found that 60 degrees angle. It actually only finds the first answer in this graph is what it looks for when you do that inverse sine. So that's why using the calculator is not really your best method. Okay, it's nice, but it won't get you all the way home. So what we're going to do is we're going to consider our little spider web chart, and we're going to think about where does the sine function equal the square root of 3 over 2. Well, we already know the first one. It happens at 60 degrees. All right. So we know that it happens at 60 degrees. That is one of our answers. It's x equals 60. So that's our quadrant 1 answer. Now, having that is helpful. So we know that at 60 degrees, we have a y value or a sine that's root 3 over 2. But there's another one right over here that we missed out on. And you can tell that they're kind of close to each other, 60 degrees and the other answer. So this is where this chart comes in. We're looking for the other 60 degree angle, or the 60 degree-esque, the one that looks kind of like 60 degrees, but it's in quadrant 2. Or in this case, it's just the reflection over here. So it's this 120 degree angle. I guess what we're really doing is we're taking 180 and we're subtracting 60 from it. Right? What I look for whenever I do these is I try to find the other spot where the y value, the other angle, where the y value is the same here as it is in quadrant 2. Right? That's what I look for. And it occurs at 120 degrees. So that's my other main answer. There's actually an infinite number of answers here. So x equals 120. So the reason there's an infinite number of answers is because the sine function actually continues to do this, little wave part right here. So it continues doing that over and over. So there's more and more intersections over and over. And it continues to do it backwards too. Right? But on the interval from 0 to 360, there's only two answers, there and there, 60 and 120. And those are the two main answers, but you can get all of the other answers from these two. What you do is you just kind of pretend that you're making another lap around the circle. You're gonna add 360 to your answers. All right, but you're not just going to add 360 once. You're going to keep doing it. You're going to do it as many times as you see fit. So this represents all the positive answers, from 60, I guess 60 plus 360, that'd be 420. So that would be another lap right here. And it also from 120 plus 360, which is something else, 480, maybe 480. But not only does it go over and over to the right, it also goes backwards. You can minus 360 from where you are now. Remember, whenever we were talking about the unit circle and that little grid, actually, let me jump back over here. So 60 degrees is true, but if you add another 360 to it, you do a full lap around the circle, you're back to 360. And you can keep doing that over and over, and you still land up in the same terminal spot. But it also works if you go clockwise, if you go minus 360. That's why when we get our answer right here, 60 and 120, we're going to add and subtract 360 from it over and over and over. And this represents all the solutions to this equation. This little part right here, that's the main solution part. That's the main part. That's from the interval 0 to 360 or 0 to 2 pi. But you have all these other ones for free just by adding and subtracting 360 to it. Sorry if that's a bit much. All right, let's do another one here. Sine of x is equal to negative square root of 2 over 2. So again, I'm going to think about that little chart. Because sine of x is negative, I know that my y values have to be negative. So I know my answers are going to be in quadrant 3 or quadrant 4. That's where I'm looking for my solutions. So where does sine of x equal root 2 over 2? What's the special angle related to that? All right, so in quadrant 1, for root 2 over 2, this occurs at the 45-degree angle. So at the 45-degree angle, we know we're going to have some of our answer. That's where we're going to find our answer that gives us root 2 over 2. But because we want it to be negative, we have to get it in the third and fourth quadrant. So we're looking for the third and fourth quadrant angles that give us a 45-degree angle. That's going to be right here at 225 and right here at 315. Those are the 45-degree angles, or they look like 45-degree angles-ish, that are in quadrants 3 and 4. Okay. So 225, that's one of them. And then the other one, was it 315? Yeah, 315. That's the other one. All right, so these are the 45-degree angles that will give us root 2 over 2 in the negative realm. But to get all of the answers, so these are between 0 and 2 pi, these are. To get all of the answers, we're going to plus and minus 360 over and over and over. So this right here represents all the solutions, every single one of them. Now, I know we've already talked about so much in this video. I'm going to mention it. We're not just going to be working in degrees. You need to know how to spell these out in radians. So here's what I mean by that. All right. What you do is you just, you rewrite these in terms of radians. So instead of it being 225, it's going to be 5 pi over 4. Okay. Instead of it being 315, it's going to be 7 pi over 4. You're going to be seeing these both ways over and over. And again, instead of adding and subtracting 360 over and over, we're going to be adding and subtracting 2 pi. 2 pi n is a lot of times the way you'll see it, over and over. All right, now this is a lot to take in first go, but we're going to do several examples of these. The next video, we're going to see some on cosine.